All right, let's dive into something that honestly sounds like it's straight out of science fiction. We're talking about building a super intelligent AI doctor, one that can diagnose cancer. But here's the twist. It has to do it using medical data it is never allowed to see.
I mean, that sounds like a total paradox, right? An impossible riddle. How on earth can an AI learn to do its job without ever seeing the examples it needs to learn from? This isn't just a fun thought experiment. It is one of the biggest challenges in medical AI right now. And solving it could totally revolutionize healthcare as we know it.
So that brings us right to the heart of the problem, what you could call the AI doctor's dilemma. It's a real tug of war. On one side, for an AI to be any good, it needs a mind-boggling amount of data to learn from. But on the other side, we're talking about patient data, which is just about the most private, sensitive information that exists.
Yeah, this really lays out the whole paradox. I mean, think about it. For an AI to get really, really good at spotting, say, a tiny tumor on an MRI, it needs to see millions and millions of examples. But all that precious data is locked away. It's protected by super strict privacy laws, and it's scattered across thousands of hospitals all over the world. Each hospital is like its own little fortress, its own data silo. You can't just pull it all together. And this creates a huge bottleneck, slowing down progress on tech that could literally save lives.
Okay, so for a long time, there were really only two ways to think about this. You had the old way, centralized training, which was a total nightmare. The idea was to gather all this sensitive patient data into one single place. You can just imagine the privacy risks, not to mention the logistical mess. It's basically impossible. But then there's the new way, federated learning. And this is a game changer because it completely flips the script. Instead of bringing the data to the AI model, you bring the model to the data.
And this is where we get to the actual solution. It's this brilliant idea called federated learning. And honestly, it's just a genius way to get around that whole dilemma. It lets the AI models learn everything they need to, but without ever sharing the raw, private patient data. So what is it exactly? Well, in simple terms, it's a technique for training one big, central AI model using data that's spread out all over the place, like in a bunch of different hospitals. But here is the most important part, the thing you absolutely have to remember. The data itself never moves. It stays local. It stays private, period.
So how does this magic trick actually work? Okay, let's break it down. First, a central server sends out a copy of a starter AI model to all the participating hospitals. Then, each hospital takes that model and trains it only on its own private patient data. Now here's the crucial step. The hospitals don't send any of that private data back. No way. Instead, they just send back the anonymous learnings, basically the improvements the model made. The best analogy is a group of chefs. They're not going to share their secret family ingredients, that's the patient data, but they will share the new cooking techniques they figured out. Those are the model updates. The central server then takes all those new techniques, combines them to create a much smarter master recipe, and sends that improved model back out for another round of learning. And that brings us to the star of our show today, a brand new framework called FedVGM. What it does is take this already brilliant concept of federated learning and just supercharges it, tuning it specifically for the really complex world of medical diagnosis.
So what's the secret sauce here? What makes FedVGM so special? Well, for starters, it's not just one AI. It's more like a dream team. It actually combines two powerful AI models. You can think of one as a super detailed expert and the other as a quick, efficient powerhouse. By putting them together, you get the best of both worlds. And it's incredibly versatile. This thing isn't a one-trick pony. It can analyze 4 different kinds of scans. We're talking brain MRIs, lung CTs, the whole shebang. And it's trained to identify 14 different conditions, all based on a huge data set of over 16,000 images. That's some serious training.
Okay, that all sounds amazing on paper, but the real question is, does it actually work? Well, the researchers put FedVGM through its paces with some pretty tough tests. So let's take a look at the results. And wow, the headline result is just staggering. When they tested it on a big, mixed data set, with all those different scan types and potential diseases thrown in together, FedVGM hit an overall accuracy of 97.7%. Let that sink in. For a task this complex and this varied, that is an absolutely incredible level of performance.
But here's something really interesting. How you combined all those learnings from the different hospitals is just as important as the learnings themselves. So the researchers tried out a few different strategies. And the clear winner, as you can see right here, was something called median aggregation. So why was it the best? Well, because it's robust, it's tough, Imagine one hospital has a weird, glitchy scanner. Its results might be way off. If you just averaged everything together, that one bad apple could really mess up the whole global model. But the median approach is smarter. It basically ignores those crazy outliers, which makes the final AI much more stable and reliable for real-world use.
And when you drill down and look at how it performed on specific types of scans, the numbers are just as mind-blowing. I mean, just look at this. Over 99% accuracy on lung CT scans. Almost 99% on brain MRIs. This proves that FedVGM isn't just a jack of all trades, it's pretty much a master of them all.
Okay, so let's recap. We've got an AI that's incredibly accurate, super versatile, and it protects patient privacy. That's the trifecta, right? Well, almost. There's one more piece of the puzzle, and honestly, it might be the most important piece of all if we ever want to see this technology in a real hospital. We have to open up the AI's black box. I mean, just think about it from a doctor's perspective. If an AI just spits out a diagnosis, cancer, and gives zero explanation for how it reached that conclusion, can a doctor really trust it, especially when we're talking about life or death decisions? For most doctors, the answer is a hard no. You simply cannot trust a black box. And this is exactly why FedVGM was designed from day one with trust in mind. It uses a special kind of AI called Explainable AI, or XAI for short. And what that does is force the model to, well, show its work. So how does it show its work? Well, FedVGM uses a really cool technique that basically acts like a highlighter for the AI's brain. It creates a heat map right over the medical image. You'll see these bright red and yellow areas, and those show the doctor the exact spots the AI was looking at to make its diagnosis. So if the AI says it sees a tumor, the doctor can look at the heat map and confirm, yep, it's focusing right on the edge of the tumor, not on some random shadow. This lets a doctor instantly check the AI's homework, which is absolutely essential for building trust.
And really, this is the holy grail for AI in medicine. It's that perfect combination of three things: incredible accuracy, built-in privacy, and genuine, verifiable trust. That's what takes a system like FedVGM out of the research lab and makes it a tool that's actually ready for the real world.
This is such a huge breakthrough for medicine, it's hard to overstate. But it really gets you thinking, doesn't it? Now that we have a proven blueprint for different groups to work together on huge problems while keeping their sensitive data completely private, what else could we do? What other massive global challenges could we finally solve?